LeetCode number 513, find the bottom left 3 value. So we have the 3 in here. So we have 1, to the left of 1 is 2, to the left of 2 is 4, to the right of 1 is 3, to the left of 3 is 5, to the left of 5 is 7, to the right of 3 is 6. So we want to find the number 7 in here, which is the bottom left 3 value. So if we go to the code and we go to the test case, test unit in here, we got 1, to the left of 1 is 2, and so on and so forth. This is how it is written in the code of the input based on that drawing. And I will put a breakpoint in here, and I will try to, let's push the debug it, whatever the word is. Let's make it bigger a little bit in here. So in this root, we have this 3. This is our root, and I don't want to explain it again. You can see it's written like that. 1 to the left of 1 is 2, to the left of 2 is 4, and to the right of 1 is 3, and so on and so forth. That's exactly what we have, and we call that root because it's in the input in here, and that will become the new linked list. Then we will initiate the queue with the linked list, and we put that root in our queue. So right now queue is empty with the size 0, and we put that root. So how to draw it? So our queue index is like the order. So if there is 1 queue, I would say index 0. There is 2 queue, I will say index 0 and index 1. So in here we have the queue with the index 0, and at index 0 we have the whole thing in here without the root. This is our index 0. Yeah, this is our index 0. Meh. Cool. And pay attention in here, while queue is not empty. So as long as we have the queue, we will keep iterate this statement in here. Right now we will reset our root into the queue poll. So queue is not stack, queue is first in, first out. What's the one that first in is the root itself, which is like from the value of 1 and so on and so forth. So in here, I want to explain about the statement in here. We place the right first and then left. Since it's first in, first out, the right will come first compared to the left. For example, if there is a value in here, which is like 6, there is no right of left in here, it's already on the leaf. However, we still have that to the second last, because 5 will be the last, because we put that the right first and then left. And 5 is still have 7. 7 doesn't have any children to the left to the right, and that 7 will become the last in the queue. When it's last in the queue will empty, and that's how we return the value of 7. That is how we know that based on this code, we always get to the leftmost of the tree. And let's see how does it work. So in this queue right now, we poll and become root. So that root still the same, but like the queue right now is empty. And when this queue is empty, so right now we are on the, let's say that's first iteration. So the root itself is the same. This is our root. And the queue right now is empty. However, if the right of the root is not empty, we offer that. What is the right of our root? The whole thing in here. 3 and 6. We offer that to the right. So in here, it's not empty anymore. After we run that statement, it will become at the index 0, 3, 5, 6, and 7. That's what we have at the index 0. And if we check it in here, q at the index 0 have 3, 5, and 7. 5 and say the 7 will be in here, yeah, in that order. The 6 also here, yeah, like this one, what I mean. And then that's our right to the root, and we also have on the second q, which is at index 1, to the left of the root. What do we have to the left of the root? We have in here 2 and 4. So at the index 1 we have 2 and 4. See, at the index 1 we have 2 and 4. And we are done with our first iteration, and we will go to the second iteration. The second iteration, we have the q.poll in here. That will become our root. What will be our root right now is the one at the q. So our root will be this one. 3, 5, 6, and 7. And our q, since we previously have 2 elements, right now we only have 1 element, which is index 0 of 2 and 4. So we check the root right now. Root right now is 3, 5, 7, and 6. That will be our root at this iteration. And then, do we have something to the right of our root? Yes, we do. To the right of our root, we have 6. And that will be in our q of the index 1. 6. And then, at the index 2, we have 5 and 7 because we are offering the left. Let's see this one first. To the q, we have index 1, that is 6. And then, at the index 2, we have 5 and 7. That is our second iteration, and let's go to the third iteration. What will be our root? Our root is like at the index 0 in here, that is 2 and 4. And then what our q at the index 1 is 6, index 0 is 6, index 1 is 5 and 7. So q root equal q.poll. Right now our root become 2 and 4, and our q is at the index 0 is 6, at index 1 is 5 and 7. And then do we have something to the left, to the right of our root? No, we don't, so we skip it. Do we have something to the right, to the left of our root? Yes, we do, and the value is 4, and we put that to the q. So at index 2 is 4. And we will finish that iteration. So right now we are at the fourth iteration. The root is 6 and the q is index 0 will be 5 and 7, and index 1 will be 4. Right, this is what I'm talking about. We are already in our leaf, but because we are on the right leaf, that is shown in here, we still have something in our queue which is like 5 and 7. Therefore, we will continue the iteration. Our stack is not empty. We continue the iteration because of this order, right first and then left. Therefore, the left will be the last. And when left has no more children, we are on the leftmost in our tree. So that's 6, and then we continue. I'm not going to draw this because it's getting simpler right now. Our queue at index 0 is 5 and 7, at index 1 is 4. I think I'm going to draw this. I changed my mind. Right now the root is 5. To the left of 5 is 7. So we are at the 5th iteration. The root is 5, 7, and the q is 4 at the index 0, and then we will add that 7 at the index 1 later. So here our Q is at the index 0 is 4, and do we have something to the right of our root? No, we don't. Do we have something to the left to our root? Yes, we do. And what's that value? That value is 7, and we will add that 7 to the Q. Not yet. Yeah, to the Q. So it will be the same like the one that we have in here. Okay, cool. And we keep going. We end that 5th iteration at the 6th iteration. We only have root of 4. The root value is 4 with the Q of index 0 of 7. We are also on the leaf right now. What leaf is this? We are on the, not really left, but like it's like one layer before. It's already on the leaf. There is no more children in here, but we still have something in our queue, so we will not end this iteration. So we have nothing at the 4 for the children, and we will have root of 7 right now. At 7, our queue is empty, and this is where we stop the iteration. There's nothing to the right, there's nothing to the left, and then our queue is empty, and we will return this value as the bottom left tree of the value. We check it, and it's true, and it's correct. So that's it.